Okay, so today, now I'm in this video, I'm going to discuss about Gaussian integration or integral, which is a very important mathematical tool, which whatever we use in quantum mechanics, in quantum field theory, in electrodynamics, and in many other topics in physics. So now, in the second video of this series, I am today discuss about the Gaussian integral. So let me share the screen. Yep. So first, if we define an integral, I, that is suppose from minus infinity to plus infinity, e to the power minus x square dx. So this is kind of well-known integration which we encounter in many times in physics in different topics. So today first we want to calculate this integration, and this is very well known, and the value of this integration is square root of pi. I'll show you. So let's prove this one. Okay. So now I can define I square. So we want to prove this one identity. So we can define this first write this integration, and I multiply with another. So I have to use another variable. Let's take y dy. Okay. So also we can write this integration like from minus infinity to plus infinity e to the power minus of x square plus y square dx dy. Okay. So what is this? So now we can try to this is okay. If we suppose it is a Cartesian coordinate system. First, let me draw the Cartesian coordinate system x-axis, then y-axis, radial part, get defined like rho, and this angle theta. Okay. So from here you can define so this will be rho cos theta. This will be rho sin theta. Okay. So what we can write here? So now we want to change the coordinate system from Cartesian coordinates to polar coordinate. Rho cos theta and y equals to rho sin theta. And here, so then what do we x square plus y square, that will be rho square, and dx dy, that equals to rho d rho d theta. Okay, this is well known to all of us. Great. So when we want to change the coordinate system from Cartesian to polar coordinate, then at the same time, so look at once again. So your I square was I square equals to this quantity. Okay. So again, so I square, that was, so there are two integrations. One is x and y. So we change this to polar coordinate, theta and rho and theta. First theta, it will be 0 to 2 pi, and to be d theta, and rho, it will be 0 to infinity e to the power. Now see, so this term will be rho square minus rho square, and dx dy will be rho d rho. I already take the d theta here. Okay, and this term will be 2 pi. And what about this term? So for this, we can do one thing. We can change the coordinate system from rho to, like, we can define z square. So dz will be 2 rho d rho. So d rho d rho, that will be dz over 2. So this will be dz over 2, and it will be e to the power minus z, and then it will be remain same. So it will be 0 to infinity e to the power minus z dz over 2. These two and these two will got cancelled. So it will be pi 0 to infinity e to the power minus z dz, and so, and this will be nothing but, so this will be 1, because it will be e to the power minus z, e to the power minus z, we have to put the limit from 0 to infinity, and e to the minus infinity is 0 with the minus sign. So e to the minus infinity will be 0, minus of e to the power 0 will be plus 1. So this quantity will become plus 1. So this will be remain like pi. So what we got? We got I square, the integration how do we define? So let me write this one here. So I, which is 0 to, sorry, from minus infinity to plus infinity e to the power minus x square dx, that is equals to square root of pi. So this is very simple, but very important. Okay, so we use this identity so many times in physics. Okay, I will show whenever I discuss in quantum mechanics, then I will show you how important this Gaussian integration. There is one more Gaussian integration. There is one more identity I can show you now. Let's consider something in I2. Okay, and I define this identity from minus infinity to plus infinity e to the power minus, let's consider like this, alpha x square plus beta x. Suppose now I have to show you how I can use this identity here to calculate this integration. So I just define one. So whatever the identity I derive here, okay, so this identity also I can use in this case, in this, to prove this identity or to calculate whatever the identity. Okay, so I2, I can write this I2 from minus infinity to plus infinity e to the power minus alpha, I take common out. So this quantity will be x square minus beta over alpha into x plus I add one term, I subtract that term. Now you can understand why I did this one. So I can write this term in terms of the square. So this will be x minus beta over 2 alpha e to whole square into e to the power is minus minus, it will be plus beta square. So this alpha and this alpha square, so it will be 4 alpha dx. So this is some constant number I can take out. Beta square over 4 alpha minus infinity to plus infinity e to the power minus alpha x minus beta over 2 alpha whole square dx. Now we can do one thing, we can change the variable once again. So we define one variable z, that is, let's consider x minus beta over 2 alpha. So dz is equals to dx. So e to the power e to the power beta square over 4 alpha minus infinity to plus infinity e to the power alpha z square dz. And now we can do one more change. Let's consider p is equals to alpha z square. So dp is equals to, so what was the formula for your formula was, so just derive one identity. We want to use this identity. Okay, so let me go back. Let's take p square. Okay, so this we can use identity here, e to the power beta square by 4 alpha, and this will be nothing but, so for this one only e to the power z square is square root of, we know this identity is square root of pi, but there is some alpha term here, so we would change this alpha, so this will be square root of pi over alpha. So this will be, so this is also very important mathematical identity. So let me summarize these two identity. What we get, the first identity we prove the Gaussian integration from minus infinity to plus infinity e to the power minus x square dx, okay, that equals to square root of pi. So if I multiply any alpha term here, so it will be divided by the second term, Our second integration we define minus infinity to plus infinity e to the power minus alpha x square plus beta x dx that equals to square root of and that equals to e to the power beta square by 2 alpha into square root of pi over alpha. So this is a two very important mathematical identity which is known as the Gaussian integration, which we used so many times in physics. So I am sure this will help you to do a lot of quantum mechanical calculation in physics. Thank you. See you in the next video.